Okay, perfect. All right, today we're going to talk about graphing again. I want to talk about the coordinate plane, the graphing window itself. Talk about the table, and we're actually going to do a couple where we actually try to graph today. So I'm going to hand out some graph paper for the most part. So we're going to do a couple things with that. And then after we're done with the basic kind of review what we did yesterday, the goal is to go into some new stuff, which is going to be talking about domain and range, which we've hinted at what these words are, but we're going to have to do it for functions now. So we'll kind of look at that. That's a part of the viewing window. It's a big piece of it. So we're going to look at domain and range. And one of the last pieces, hopefully we can get to it today, is to talk about how to actually graph with a calculator. And that's what I want to kind of end with today, and kind of show you how my calculators work and how you can type stuff in, how you can graph, in case you ever had to do it before, or if you have to do it in the future, that type of thing. So that's kind of what I want to go through today. It's pretty chill little day, but I want to just make sure you kind of know what you're doing. So first thing I want to do, let's hand out some graph paper because you're going to need it. Okay, so here's some graph paper. This is just going to be for your notes. Just hold on to that. So I'm going to use this. When we get to homework that we actually have to graph, you'll get some of this, but I don't know if you'll need all 12. I'm giving you a ton of them just for the next week or two that you can actually use this. Okay, everyone get one? Perfect. Okay, so graph paper, make sure that the Y is at the very top, X is off to your right. If it's not, turn the paper, make sure it's oriented, make sure you don't have it upside down. It's not a big deal, it's just one of those things like it's a pet peeve. Some people like to turn it sideways and have it in landscape as opposed to portrait. It's not a big deal. So make sure you have it up. I'm going to pop it up here on the screen. We're going to use that. Okay, the goal is to graph. So off to the side, we're going to type in one of our first functions. We're going to talk about how to actually graph on this graph paper. So here's what I'd like you to write. I'd like you to write f of x squared plus 3x plus 2. I'd like you to write that down. We're going to talk about graphing. This is kind of one of the problems you've seen before in this class. We've actually talked about that specific problem. But we're going to go through and talk about how it applies. Let's start doing now. What this appears here. Okay. What I want you to do first on your x squared plus 3x plus 2, make a table down below it. So we're going to talk about graphing and how to put it into an actual graph itself. But what I'd like you to have is a table. Okay. In your table, tables have x's and y's to get in more, and we'll talk about that here in a second. We're going to pick a bunch of x values. What I mean by a bunch, I'm talking maybe 6 to 7 different numbers, maybe 8 different numbers. And we're just going to kind of go from left to right on the x-axis. So we're going to just stay small. I'm not going to go bigger than what's needed on this graph. But let's say we start at -3, and we're going to work our way up to +3. So we're centered right over the origin. So the dots I'm plugging in are all the values from -3 and up. On this graph, these are the values. Now, the good thing is about a graph is that you can actually scale it to anything you want. It doesn't have to go by ones. I'm choosing to go by ones because it'll be kind of easy to see this. But you can go by 2s, you can go by 4s. It doesn't really matter. You can go by halves. You can go by decimals. Okay, so these are the numbers we're plugging in, the x values. That's called the independent variable, right? The thing you're in control of on your problem. Now, on your problem, the x squared plus 3x plus 2, there's a couple different x's. So when you actually pick one of these numbers, we're going to go in order, so we'll plug the -3 in. You're actually going to plug that number into all the x's on that problem, right? That's, it's what you did in Algebra 1. It's basically just plugging in numbers, computing, spitting out a y value, spitting out what the function value's answer is. So the first one, I'm going to plug in -3. we're going to square it. You're going to add that to negative 3 times 3 and add that to a 2. Like that's what you're doing when I plug in that first number. I plug in this first negative 3. So negative 3 squared is 9. Negative 3 times 3 times negative 3 is negative 9. And then you're going to add 2 to it. And what happens here, this turns out to be 0 with the first 2 plus 2, which is 2. So I'm going to graph the first one. We're at 2. So at negative 3, we're at 2. There's your first dot. Now we're going to keep going. We're going to keep graphing here. So the next one we're going to plug in the negative 2. Now, if you had a calculator, this is something I want to show you, that you can actually type in a formula on a calculator and hit enter and it will spit out the values for it. Most calculators, other than like simple, easy looking calculators, they actually have this function where you can hit like an arrow key and it will bring up the previous problem you just did. And then you can use the arrows to go back and highlight a number. So, for instance, let's see if I can bring one up here. I don't know if I have a calculator anymore here. I don't know if this works. It's not going to work on that. Alright, so, anyway. Okay, the goal is to show what I'm talking about here. So, let's see if I can do this. I don't know if this will actually work. It's going to seem a little weird what I'm about to do. Hopefully this will look okay. Here we mark up 4. Okay. Yeah, that works. Okay. So, ignore the big scratch on my screen here. If I can try. Alright, so graphing calculator rate, pretty straightforward. The big thing about on the graphing calculator itself is you can put it into different modes. You can type in like formulas like that thing right there, the x squared plus 3x plus 2. So where you actually find that is this y button right there. So it says stat plot, it's the y equals key. When you actually hit that button, it brings up formulas you can type in. So the idea is that, in fact, I'm going to balance this. So when you want to type something into this, what you can actually do is they have a variable key. The variable key is right below the mode button. It's right there. So you can hit X. That's your variable. It can be any letter of the alphabet you want it to be. It's usually just any as X. You hit the little caret key. You can type in the 2. I'm going to hit the plus 3x. So 3. I'm going to hit the little X key again. So that's that key right there. And then I'm going to add 2 to it. Oop, not 20, but 2. So I'm going to go back up and hit 2. Delete. Okay, so what you're looking at here is I have my function typed in, and it's written in the correct form. Notice I didn't have to use any parentheses. The newer calculators require that you actually put that power of 2 in a parenthesis, so it knows that's the only thing you're putting in the power. Yeah, ignore the little crack in my screen, sorry. I had it up in my car during winter and cracked the screen. But the big thing I want you to notice is that the equal sign here has like a black box on it, because that means that formula's been activated, so I can go graph it, I can do other things. Well, without graphing it, because most people won't know how to graph, what you can do on some of these calculators is you can use like a table itself. It actually has a table button, so you can actually enter a table and you can set like what parameters you want it to go by. You can actually just type in like numbers into that problem and that'll actually tell you what answers are. That's the feature I want to show you. So notice what is the y value over here? Which number is that? So it's the y1 number. So that's my first value. That's my first function. I can type in, I think I can go up to 100 different functions. I can just keep scrolling down. So I can type in a bunch of these and hit enter. Well, why that's useful, so if I actually escape out of this, I'm going to hit second and quit. This is the normal home screen where you type everything in. 2 plus 2, hit enter, and it gives you scores. Well, what you can do is if you go into your variables, there is a, let's see, where's the variables? There. This button right here, variables. You hit variables. It brings up the thing where you can change the window, you can zoom, you can go to the graph, you do other things from here. But the interesting thing is if you scroll over, you go to the y variables and the functions. Why that's important is because if you hit enter, it brings up all the functions that you've typed in previously. So you can have these all programmed in from your homework. Well, if I hit enter, now it's saying, hey, you're using the y1 function. So again, that was under your variables. And you're typing the y1, so that was from that mode over. And now what I can do is after that, I can type in any number I want into that problem. What was the number I plugged in? What, -3? So I'm going to type in -3, close the parenthesis. When I hit enter, it spits out the answer what the function should be. It's like substituting it in. So it plugged in -3 into my whole problem and just does it for me automatically, which is kind of cool. And then when you hit the arrow keys, so I use my little arrow keys, I can go back and go back up to this original function that, that function I just typed in, and I can type in another number. So if you have one of these calculators, most people have like little text instruments, the one that I have on my wall over there, you can hit the little up arrow and go to it. I think on this one you actually have to hit, shift and I think it's enter, yeah, shift enter, and it brings up the formulas again. Now if I keep hitting shift enter, it brings all the ones I previously typed in. But again, I'm going to go to the next number. What was that, -2? That was the next number we typed. So I'm going to use the arrows, go to -2, hit enter, and this is the value it should be. It should be 0. So, again, I'm just going to keep going here. So far the first one gave me a 2, the next one gave me a 0. We're going to keep going. We're going to type in -1 next. And we can just type these all in. Now, what will save time is that this thing can do tables. So it can actually set a table for us. So on this, to set like what the table set is going to be, like what it's going to jump by, what number I want to start with, I have to hit the little shift key and then hit the table set button. And the table set button allows me to tell me what number I want to start at. I want to start at -3. I want to jump by 1s. So I'm going to jump by 1s and hit enter. Okay. And hit enter and enter. This is all automatic. So I'm starting at -3. I'm going up by 1s. That's the delta table. It's changing by 1s. And when I hit my shift table button, it gives me a table that started at -3 and goes up. As you can see, it started at -3 and it's going up through 3. The table automatically does it for you. So the numbers I'm going to get. So I'm going to get 0 for -2. I'm going to get another 0 at -1. I'm going to get a 2, a 6, a 12, and a 20. So it's plugging in all the values for me, and that's the beauty of having one of these calculators. Because most people always ask, well, why would you buy one? And I agree, like it's $100 some sometimes for these things. But this is actually like the purpose of what we use it for in like mathematics, is so that it can actually do a bunch of values for you automatically. You don't have to put any effort to actually figure it out. And it gave you a whole table set. In fact, it can even graph it, which we're going to do by hand anyway. All right, questions on the actual graph itself? Okay, or the table, I mean. So what I just did basically with the calculator is these were all entered in one at a time, and these were the values coming out of this thing, like as it was spitting them out. Okay, but on most calculators, you can just type it in, go change a number, hit enter again, go change a number, hit enter, and just keep going. In fact, can does somebody have one of those Texas Instruments on them? The one that, like mine? Can I borrow that? Cassie, can I borrow your calculator? Show that one, just to show you how to fix it. Because this is what most people use because they borrow mine, which is fine. Alright, so, let's see if I can, gotta get away from that light. The light is terrible. Okay, So, it's not working. Alright, that'll be about as best I can do. Okay, so to type in that problem, what I would normally do is I'd type in like the -3 in a parenthesis and then square it. So use a little caret key, square it plus, what is that, 3 times -3 in a parenthesis and then plus 2. And hit enter. And that's when it gave me the number 2, right? And you have it in science. Take it, fix that so you can see a bunch of decimals. But what I can do on these calculus text instrument ones, if I typed everything correctly and I used parentheses in the right spots, like how I wrote it over there, I can hit the little up arrow. It puts me back up to what I was typing, and now I can just scroll over and change the numbers. So I can type in -2, go over, type in -2, and now hit enter because everything should have been the same values. So as you can tell, now it's 0. And I can keep doing that. And so it's kind of like the table like I just did here, but you just do them really quick. You can just hit enter. Okay, questions on how to usually go back in some of those menu-driven. I call this a menu-driven calculator because you can actually see what's written, and then when you enter, you see the answer below, and you can keep going back to what you've previously written. Some of those other calculators, like really simple ones, I don't know if I have one here, I don't, where they don't have a menu, you can't go back. It's like when you type that problem in, it's done. Like it's doing it automatically. So, all right, but there you go. Thank you for letting me borrow that. All right, so what I want to do is graph. So I know we're graphing by hand, which is silly. We can use technology. We can use our Chromebooks eventually and graph. But I want to talk about how to actually type stuff in on the graph itself. So let's go back to overwrite that. Perfect. Okay, so here's my graph. Okay, so here's my graph. So we're going to plot all these points. So again, go to that first graph. Hopefully, if you haven't already started, you write that down like right above it, right above that graph. So write that like over here or above it. And put this table off to the side, and we're going to plot these. These are actually coordinates. The x comes first, y comes second, and we're just going to plot each of these points on your graph paper. So -3, -2, -3, 2, -2, 0, -1, 0. We have 0, 2, 0, 2, 1, 6, 1 over 6 1, 4, 5, 6, and 2, 12. And how I can get into these spots really quick is that the graphs go by 12s. When I give you a graph, it always goes by 12. That's usually how it's supposed to work. Now, I can't graph 320, it's off the graph. It's fine, you don't need to even put it in there. What is this starting to look like to you? It is a parabola. Something that hopefully you've heard that term in Algebra 2 a little bit, but if you didn't, parabola is a very symmetrical looking picture. It's basically a bowl, okay? It's just kind of a curve. What gives it away is that it has a degree of 2. So degree 2. So anytime you have powers that are greater than 1, so higher than a first degree polynomial, you have curves. So a square or parabola is called a quadratic, and quadratics are curves, and they're very symmetrical. So like when I was over at 1, 6, this next spot over is what? What is this, -4, 6? Because it's got to be perfectly balanced between all the points. So there is an actual turning point. So over here, this one will be right here, because it's going to be perfectly symmetrical. Now the problem is, I have no idea where that spot is. That's something that we'll learn eventually, where those inflection points are. That's a part of calculus. So how to find those spots, how low they go, all that good stuff. All right, questions on graphing right now, like the concept. Right now, you guys are at the point where I trust you to set up a table, plot the points. Does that make sense? Like just a few of them. And you know, like if you're looking at the picture and you didn't quite know what's going to happen, plug more numbers in. Go -4, -5, -6. And then set your new table and you can see what it's about to do, and that's the graph. That's kind of where we're at right now. But by the end of the chapter, we'll be able to look at a problem like that and plot it, like actually graph it without having to do a table for it. We'll have very distinct ways of like breaking it apart and doing all the little parts of it to actually graph that. Okay, the parts that we're going to eventually learn is like end behavior. End behavior is like where the tails go. We'll talk about x-intercepts, y-intercepts. We'll talk about inflection points. Inflection points is that turning point, it's like where it oscillates from like positive to negative, that type of thing. Min and maxes, that's something we're going to learn in this chapter, the first chapter, chapter 1. So you learn little rules, and they're really quick rules. It's not meant to be like super difficult. You can do it without really having to write anything down. You can look at that formula, and there's little tips and hints that it's telling you how to do it, which I think is kind of a cool concept. But questions on plotting with graphs and the calculator itself. I know, like, we're going to look at the calculator more and more. I'm going to try to. I have an electronic version on my MacBook that I'll use instead of having the weird iPad pointing at it. I thought that was just kind of an easy way to do it for a day. But all right, questions on the coordinate plane though. Okay, everyone understands the x and y axis and how to plot points. Everyone feels comfortable with that. Okay. All right. Next, let's talk about the viewing window. Because I want to talk about like this window here, and then how to change it on a calculator. So I'm going to go back to the calculator here in a second. So viewing windows. I think we hinted at this one yesterday. Okay, so for the viewing window, it's comparing the x's versus the y numbers, right? And when they write a viewing window, they always use the boxes themselves. Like there's like, they're not curly braces, but actual braces. Like this. This is how they write it. We'll talk about how to change the viewing window on a calculator because it looks a little bit different. But what this is there's 3 numbers in each of these. These are going to represent the x-axis on a graph. This is going to represent the y-axis on a graph. Now, why this is important? It basically is telling you how to do domain and range. That's what it's kind of pointing at. So on my graph, what is the lowest x number on the graph that's on the paper in front of you? Say? Negative 12, right? You always put the minimum number for the x right here. What's the maximum number for the x? 12. And what are the boxes jumping by? Ones. So we put ones there. That's a viewing window. It tells you what's the lowest number, what's the highest number, what do you jump by? Or what they call delta x. What's the changes in x's? It's going by ones. You can change a viewing window to go by halves, by twos. Because I said on this graph, you can relabel them. It doesn't have to go by ones. You can jump by 2s or 4s or 10s or decimals because maybe you need to get really small objects in there. Okay, for the y-axis, same exact thing. You're going to have a minimum, you're going to have a maximum, and you're going to have what they jump by. So again, minimum, negative 12, maximum is 12, and it's jumping by ones. So that it actually plots out a graph. And it will hopefully look like a picture like this. Now, I want to show you on a calculator so you can actually see what this should look like. So viewing windows are kind of important. If you don't know your viewing window, you won't see the whole entire graph or see what it's doing. So let's take my calculator again. Let's put this back in the projector here. Okay, so let's, you guys see that? Yeah, someone. Okay. Well, all right. So to graph on a calculator, we have to change the viewing window. So viewing window is the window button right here. So you're gonna hit it, and now it has all the numbers we just talked about. So minimum x, maximum x, with the scale you want to jump by. So they're just going vertical. It's not going horizontal like my little boxes over there. So I want to go by negative 12s. I want to go up to a maximum of 12 and then jump by ones. So there's my x-axis. I'm going to go down to the y-axis. Same thing, I want to jump by negative 12. I want to go down to 12, and I want to jump by ones. Okay, there you go. Okay, we're going to graph this. Now to graph in a calculator, you're going to just hit this little graph button. But you have to make sure before I hit the graph button that in your y functions, your graph is actually activated. So there has to be like, geez, sorry. you have to make sure that the little box is actually darkened. If the box is not darkened, you won't see your actual graph. So that how you actually change that is you just use your cursor and highlight it, and when you hit enter, it turns it off, as you can see. Like now it's off. It won't graph it anymore. It's like an on-off button. So if I go highlight it again, hit enter, it'll be darkened. Let's put that, sorry, instead of a random button. Yeah. So it's actually activated because it's darkened. Okay, that's that little equal sign. Now to graph this, you're gonna hit the little graph button because we already changed the viewing window, we're good. So now this viewing window is exactly the window you guys have in front of you. It's going by 12s each way. You can actually see that it's hitting certain points. It's hitting -2 and -1, it's hitting +2 on the y-axis, it's kind of going up, it's very symmetrical. That weird spot right here where it's kind of dipping down, we still don't know where that's at. So it's very similar to the graph you have in front of you. Now, if you want to zoom in, you have a zoom button. So you can actually hit zoom, you can zoom in and out, you can zoom by boxes. If you zoom in, you actually hit the zoom in button. You can actually hit enter and it'll just keep zooming in. And if you keep doing that, it'll get smaller and smaller and smaller. So right now the scales are going by 1 still, but it's not showing all -12 to 12 anymore. You know, I'm going out to, what is that? -3 up to 3, and -3 to 3 vertically. So that was kind of the numbers I picked from my table. The pecker just kind of goes by those. And then I can find certain points on here, because I can trace. So they have a trace key, as you can see it. They have a trace key, and so you can actually trace values. Perfect, thank you. Status changed. Okay, but if I want to trace and I want to figure out like where that little dip on the graph is, I can hit the trace button, and now what it's going to do is it's going to move my cursor. As you can see, that little like blinking dot, and if I move my arrows, I can eventually trace. And what you're seeing at the bottom is the actual coordinates where I'm at on my graph. So I'm almost at 1 on the y-axis, but I'm about, what is that for? -0.38 and up 1. So if I keep moving down, I can eventually figure out what that little dip is. That little dip is about -1.5. It's right between 1 and 2. So that made sense because everything's very symmetrical. So it's in between -1 and -2. So if I actually want to calculate, like, what is that dip? Because right now I'm kind of guesstimating what it is. I'm just using that cursor to get close as I can. If I actually want to calculate what that number is, there's an actual calculation button. It's right here, it's F4. You can see it's right there, calculate. And what I can do is if I hit Shift Calculate, it'll ask me what type of calculation do I want to figure out. Do I want to do a certain value? That's what I want to do. Do I want to figure out a 0 where it hits the x-axis? Do I want to figure out a min and max? It can do that, which would be the same thing here. I can figure out where it's intersecting certain objects, so if I have multiple graphs crossing, it'll actually figure that stuff out, which is kind of cool. I'm going to do a value. So what I want to calculate is what happens when I type in a certain x number. Well, what was the x number I was looking at? What was I in between? -1 and -2, so I'm at like -1.5, right in the middle of it. That's the number I'm going to type in. So I'm going to type in -1.5. When I type that -1.5 in, it will give me what that lowest spot was. So the lowest spot is -0.25. It knew exactly where that spot was. In fact, if I would have done, if I did calculate again, like Shift Calculate, I could just do a minimum too. So I could go down, I could hit minimum, and it could just tell me that right away. And it actually tells me, like, it asks me questions like, what's my left bound, what's my right bound, and I can type that stuff in. And what it wants by left and right bound, I just use my cursor and type in, I want the right bound, hit enter, and it has a guess. It wants me to guess, my lowest point's about right there, and it'll actually do the calculations and it tells me that anyway. So So if you didn't know, like it wasn't perfectly symmetrical, all you have to do is pick a right and left, and then pick where you think that lowest point is, and watch it figure it out for you, which is kind of sweet. So like these graphing calculators can do some serious math. Like that's doing a lot of calculations in the background, but it's pretty impressive, like what it can do. Okay. Questions on the graphing calculator? I know it's like something you probably, how many have actually used a graphing calculator? Okay, 1, 2 people, you have your own, and you probably have one.
Yeah, middle school they had them for all the students.
Yeah, so it's like one of those things like, I don't know if you need them anymore, because everyone has cell phones, you have computers where you can just type in stuff, but it is actually super useful, just because you don't have to be calling clunky keyboards when typing math. But, I mean, I don't know if it's necessary. But, there you go. Alright, let's talk about domain and range. Domain and range is the X numbers and the Y numbers, right? It's not just viewing windows. Domain and range is like, when you look at a graph, does it flow continuously left to right? Does it have stopping and starting points? That's something we're going to eventually talk about. Same with like end behavior and, you know, the inflection points. But this domain and range idea is directly kind of based on what you thought the viewing window is. This gives you a sense. Because if you kind of know where the graph starts and stops, then you have kind of an idea of what the viewing window is that you want to look at, and that helps you figure out domain and range. Because you know what your minimum number is going to be, your maximum number, and all that good stuff. So that's something we're going to look at next time. All right, questions with any of the stuff I've kind of discussed or intro today? Okay, tomorrow, bring your textbook. We're going to plot some more stuff tomorrow, and we're going to look at how to calculate some of the stuff. We might actually go into like, bring your Chromebook tomorrow. We might actually plot some stuff on the Chromebook because there's graphic programs that we're using there, which is pretty sweet. I'll try to do that. Okay, questions at all about graphing? Good. All right, that's it for today. I want to keep it nice and light, pretty easy today.
Have you seen that? There's a